Yes. So the input wave is 200 hertz. You can increase it, you can decrease that. All that is possible. And oscilloscope gain, you can increase the gain. Amplitude you can increase, you can decrease. Amplitude vertically you can increase and decrease. Right? So, and seconds per division, 1 millisecond per division. In our CRO, there is a knob called as volts per division, times per division knob. Right? 1 millisecond division, 2 millisecond division. If you change the division, frequency won't change, but the number of cycles will increase. Okay? So that is what is the concept that you have to understand from this, okay, simulator. Now volts per division, if I consider one division, the 1 into 5 is 5, right? So the number of I have reduced the volts per division, so the voltage gain has increased, right? Now if I decrease this, if I keep it at 10, then what happens is because this is at this is volts per division is at 10, 10 into that, 10 into that will be that much. It will look that much only, right? So resultant it will show on the screen, right? So by changing this, the amplitude and time period will not change. By changing the knobs in the CRO, the actual values will not change, right? So now coming to the next one, vertical offset. You can increase you can take the waveform up and down. You can take the waveform left and right. All that is possible with this, okay, knobs, right? This is one such a simulator, right? So sound that and all, if you want to simulate acoustic sound, so that also you can do it, right? So waveform, the different oscilloscopes are there. I didn't go into this. My intention of showing you what is on my oscilloscope, you can browse, explore those other options, right? So this is one such oscilloscope. Clear to all of you, right? I will share the simulators in the Google Classroom at your convenient time. When you get time to do some work, if there is no other party to play the games, that time you can see this particular simulators, right? So the next one, the next simulator is going to be this one. So this is another simulator. This is another simulator where frequency selection, this is what is the function generator. Now sine wave, triangular wave, square wave. You can change the type of the wave, sine wave, square, triangular wave and square wave. And frequency also you can increase. See that this is what is the signal. Now if I increase the frequency, see the signal is very close. The time period have reduced, which means the frequencies, okay, frequency decrease and time period increases, then frequency, like time period, if it increases, frequency decreases, right? So reciprocal to each other. So this is 1 kilohertz. So this signal you can see here. If you click on this, you can increase the amplitude. Now if you click on this, you just have to, just like a knob, right? So you try this particular simulators. All these things you can try, okay? So you can see the waveform. Now let us suppose whatever you talk, you want it to be displayed on the screen. That also is possible just by taking toggle music. Whatever we are talking, that signal, it looks like that. Okay, looks like that. Right? So it will take the data from the information from the mic of this particular laptop, and that will be given to the CRO. You can see the variation in the amplitude of the signal. If I say the signal loudly the amplitude of the signal is increasing. Okay, now if I say slowly, then the amplitude remains very less. So loudness is something related to the amplitude. Okay, so already is possible with this particular simulator. I felt okay, this option is good in the simulator, that's why I have just copied that link and thought of showing it to you. Okay, now the next one is going to be the next one is this particular one, virtual labs. Virtual labs, this is a very basic level. The students generally, those are beginners, uh, they look into this particular, if you look into this, it looks very very basic level. After seeing the remaining simulators, if you see this simulator, that is completely different. These simulators are designed by the professors as well as the research students on their own. So this is not given to the third parties for the design. Okay, so now I'll just show you this simulator. This particular simulator is designed by IIT Kharagpur. Kharagpur. Okay, so you can browse for virtual labs. Virtual labs. So virtual labs. So these are the objectives of this particular virtual labs. Okay, just go through that later at your convenient time. My intention is not to give you the details about what are the various virtual labs available. Okay, now we'll go through this particular simulator. So here you can't do, you have to follow the instructions, then only this will work. Okay, the first instruction is here, the instruction: connect the component as mentioned below. Connect the component as mentioned below. L1, L5, L1, L5. This is 1, this is 5. This is function generator 1, this is function generator 2. Okay, what is a function generator? It is an instrument which is used to generate waves. You can generate sine wave, square wave, and triangular wave, or a wave of your choice, right? So 1 to 5, click and drag and drop here, click, drag and drop here, right? Now the next instruction is L3 to L6, L3, L3 to L6. Next instruction is L4 to L7, L4 to L7, L2 to L7, L2 to L7, then and then that is over. Now you click on. Yes, we'll see the instruction. Now click check connections. Click check connections. Right connection. Okay, let me show you how foolishly this code is designed. Okay, so deselect all. Yeah, he said you connect 1 to 5. No, I'll connect 5 to 1. Okay, 5 to 1. 1 to 5, 5 to 1, both are correct. No, okay. Uh, why I should give this one only? I'll give. Yeah. So 1 to channel 2, 3 to channel 1. This to this to this I have given. Let us see whether it will say that is right or wrong. I didn't check. Check the connection. Wrong connection. But that is a right connection. But that is a right connection. Okay. But it is saying wrong connection because they have written a code. You have to, as I told you, that you have to follow the instructions. Those instructions, they have written a code in that line only. Okay. So delete all. So right. So 1 to this, 3 to 2, 3 to 6, and then ground to this and this to this. Check, right connection. And then switch on. Switch on. Now sine wave, frequency, amplitude, Okay, and you can see channel 2. Channel 2, this is channel 2, this is channel 1. Frequency, amplitude, square wave. You want to see both the waveforms. You want to see both the waveforms. Yes. So dual, both. Okay. So that is also a coding mistake. Should show us both the waveforms. It is showing us both the waveforms. Yes. Cleared all of you. So these are the various simulators. You try at your convenient time to get the familiarity of the CRO. Right.